Okay, so let's go ahead and go over number 10. Last question I had or last homework question I had a question about. It's hard. It is an extra credit question for a reason. You actually got two steps to it, okay? So let's go ahead and figure this out. So let me read off the question. A record player starts from rest. Okay, so rest means that it has zero speed, right? And it's at an angle of zero. So its initial theta is also 0 radians, okay? It has a constant angular acceleration, okay? But it doesn't tell us what that is, so that's a pain in the butt. Still a question mark there, right? And it rotates to a counterclockwise angular speed. Okay, so counterclockwise meaning this way, so it's positive, so that's cool. And its angular speed, so it's angular velocity now because we also have the direction with the speed. Its final angular speed, its final angular velocity is 99 radians per second. And it eventually stops, right, at that time, at some time, it gets to 62 radians. That's how far it goes in terms of its angular position. So it wants to know how long did it take to get there. Okay, so that we can't get to time immediately. If we look at our equations, we've got theta, if we look at that one, theta final is equal to theta initial plus omega times time plus 1/2 alpha times time squared. Well, we got time and alpha in there. We got two unknowns, right? Two unknowns in one equation, not going to work. Okay, so let's keep moving on. We got our omega final, okay? That's equal to omega initial plus alpha times time. Two unknowns stuck together. That's not going to work. What else do we do? The only other option we got, timeless equation. All right. Almost wrote A there again, right? 2 alpha times theta, okay? So, timeless equation, there's no time in there. We've got acceleration in there. Let's look at all our other variables. Initial angular velocity. We got that, 0. Final angular velocity. We've got that, it's 99 positive, right? We've got 2, okay, there's a number. Alpha, well, we don't know that, okay, so we got one unknown so far, but maybe this can work. What about theta? And this theta has to be how many theta you've actually gone through, how many radians you've actually gone through total by the time you want to find this number, right? Or sorry, by the time you want to find that angular number, right? So if we plug this in, what we have, okay, we've got our final radial position, which is 62 radians. We got everything. We can actually solve for alpha here. But remember, the problem doesn't ask for alpha, it asks for time. Okay, so first step is going to be to use the timeless equation. Second step, it's up to you. You can use whichever one you want, okay? Omega initial is 0, so this is going to come out to 0. Initial position 0, so it's going to come out to 0. So you'll have theta final, which is 62, is equal to 1/2 alpha t squared. We're about to find our alpha, so you could use that one to find time. I probably wouldn't. It's going to be cleaner to do this one, okay? So my second step will be this one, even though either one of those equations will work after we find that alpha from our timeless equation. So pain in the butt. If you don't have time and something else, again, if you don't have time, the way you should go is timeless, right? So let's work out timeless, okay? So omega final, we know is 99 radians per second. We're going to have to square that, okay? Omega initial, that was 0. Easy enough, okay? Plus 2 times alpha, which we don't know, and our final position, which was 62. 62 radians, okay? So we want to solve this. Well, the 0 drops out, okay? We got to get the 2 off of there to solve for alpha, so we'll divide by 2, okay? And we also have to get the 62 off of that side, so we're going to have to divide by 62 radians, okay? So that ends up on the bottom here as well, okay? So if we solve this part first, 2 times 62, we will get 124, okay? And then we can get our alpha, okay? So 99, square it, divided by 124, you got your alpha value, okay? Now what you want to do next is you'll use step number 2. The one I'm using here, again, you can use either one. Either one's okay. I'm going to use this one because it's a little bit less stuff to put in, and it's only t instead of t squared. We don't have to put in a square root, right? Fewer steps. So omega final here we know is 99. Okay, so let me write this over here. 99 was our radians per second was our final omega, okay? Initial was 0, so I'm not even going to write it in. Okay. Alpha, we just found out it's this big crazy number, 99 radians per second. All that squared over 124 radians, right? And then, so that's our alpha and our time. We don't know yet. We want to solve for it. So work this number out, divide this number by that number, right? And you'll get your time. And that's it for number 10. Okay? Thank you, and I hope you're doing well otherwise, okay? Talk to you guys soon.